Hi guys, let's take a look at this question where we have two test tubes A and B that both contain a sodium salt solution, and it's called barium chloride solution. After a small amount of barium chloride is added, the solution in both test tubes forms a white precipitate. Okay, 9.1. Write down the type of reaction that takes place in this test tubes. It's called a precipitation reaction. Why? Because in the information section, they do tell you that after the solution is added, a white precipitate forms. So it's a precipitation reaction. 9.2. A concentrated nitric acid is then added into each test tube to establish which one contains carbonate ions and which one contains sulfate ions or sulfate ions. Bubbles are formed in test tube A and there's no reaction in test tube B. Identify which ions, carbonate or sulfate, are present in test tube B. That's going to be the sulfate. 9.2.2. Write down a balanced chemical equation that represents the reaction between nitric acid and the precipitate formed in test tube B. All right. So remember, there was barium chloride, and in test tube B, it formed a carbonate, right? And then we have nitric acid. Okay. So then, we have a white precipitate after adding the nitric acid, etc. Right, so this is going to be our chemical equation. How do we balance it though? One barium, cool. One carbon. There's 6 oxygens here. There's 6 oxygens there. 7, 8, 9 oxygens. So what can I do to make this also 9 oxygens? If I add a 2 here, right, that will be 6 oxygens plus 3 is 9 oxygens. But now what happens? I have 2 hydrogens and 2 nitrogens. But that's fine because I already have 2 nitrogens as well, and I have 2 hydrogens. And that will be my balanced chemical equation. 9.3. A solution of sodium carbonate was prepared by dissolving 5 grams of powder in 100 centimeters cubed of water. The solution reacted with barium chloride solution according to the following balanced equation, right here at the bottom. Calculate the mass of barium carbonate that should form in this reaction. So we want the mass. So we obviously will then need the number of moles, the molecular mass to get the mass, right? So let's start by determining the number of moles of sodium carbonate. So they've given us the sodium carbonate, which is 5 grams, and we can calculate the molar mass by taking the atomic mass of sodium times 2, carbon times 1, and oxygen times 3 because it's sodium carbonate. Okay, so that answer is going to be 106 and I get 0.04 moles. Okay, so now I have that. So they want the mass of barium carbonate. So they want the mass of this one here. So we now have the number of moles of sodium carbonate, right? But we want the mass of barium carbonate. So we also then need the number of moles of barium carbonate. But we don't have it, but we can calculate it using the ratio. So if you look, there's an invisible 1 in front of all of them. I'm just going to show you that. Number of moles of barium carbonate to the number of moles of sodium carbonate. It's what we want to what we have, all right? So they are 1 to 1. You can clearly see that's 1 to 1. So therefore, if the number of moles of sodium carbonate is 0.04, the number of moles of barium carbonate is also going to be 0.04. Okay. Then I'm going to just go all the way up here and continue my calculation. They want the mass, right? So remember the calculation is that. So now we have 0.04. We want this mass and we can easily calculate the molar mass, right? We just go back to the periodic table. Okay. So we want barium carbonate. So we're looking for barium's mass, and there's only one barium atom, so it's 137 times 1. We have carbon again, 12 times 1, and we have oxygen again, 16 times 3. And all of that together will give me 197. So then I'll multiply these two, and I get 9,26 grams. Then 9.3.2 I'm going to do at the top here. Then it was found that 8.39 precipitate was formed. Calculate the percentage held. So percentage held is actual held divided by theoretical held times 100. So our actual held is what was formed, that was found to be formed, and that was 8,3. Our theoretical held was what we just calculated, the mass of barium carbonate that should form. That's the theoretical held. So that's going to be 9,26. And we're going to multiply that by 100. I'm going to put that into my calculator, and I'm going to get a percentage held of 89,63%. And that's it, guys. See ya.